In this lesson, we're going to talk about how to prove trigonometric identities. So first of all, what's an identity? We know what trigonometry is, at least we're learning about it. But what's an identity? In math, an identity is also called an equality relationship, and you've been working with them your whole life. An identity in math is any equation that is true for all values of the variable. Okay, so for example, 5x minus 1 equals 5x minus 5. There's a very simple identity, right? We could obviously distribute this and prove, 5 times x, 5 times 1. So I'm just giving a basic, simple example, just something to think about as an identity, right? Okay, so what's a trigonometric identity? Well, a trigonometric identity is an identity involving trigonometric functions. Trigonometric functions, right? Now, we already know the basic identities. We've actually talked about them. We've proved them back over a month ago. So let's just highlight them down here. We already know sine, cos, and tan. We've proven them. We've proven in the previous unit where they came from, how we developed them. We showed, again, this is going back to our full unit before the break. And then we also talked about the reciprocal identities. So we've covered this, right? Cosecant is 1 over sine. Secant is 1 over cos. Cotangent is 1 over tan, right? So those are called the reciprocal identities. We've discussed those. So nothing new. So there's really not much new here. Let's look at, we've also talked about what tan is, right? We've proven what tan is. Tan is just sine divided by cos. And another way of looking at cotangent, instead of describing it this way, anytime I see cotangent, I can replace with cos and sine. So what do I mean by replace? Well, what we want to do is we're going to be proving that one side of an equation is equal to the other side of the equation. And what we want to do is generally, there's some different tips I'll give you, but generally when we see cosecant, secant, or cotangent, we want to replace it with these. And generally when we see tan or cotangent, we want to replace it with these. All right, so now, there are other ones, the Pythagorean identities. Now, the truth be told, the only one you need is this one. This one is huge, and it's the one you got to really kind of memorize. Long story short, now again, let's prove why this is. We've done this before, but let me just draw a little diagram. I'm going to pause here and draw a diagram. Okay, so I just drew a quick diagram up here at the top. Now again, you'll have to go back to remind yourself from our previous unit. But remember, going back to the unit circle, remember how we can have x and y. That's a point on the unit circle. There's x and y, right? But remember what the definition of sine and cos are. Sine and cos are originally defined as the coordinates, right? So given an angle here, right? Cos would be the x-coordinate, so cos theta, and sine would give us the y-coordinate, right? So that allows us to also describe this triangle's lengths, right? Because the length of the side, that's our y-coordinate, right? The length of this side gives us our x-coordinate, and we have a radius of 1. So, again, I'm kind of summarizing really quickly something we've talked a lot about here. So, long story short, we have a triangle that has sine for the length of this, cos for the length of the bottom there, and the radius is 1 on our unit circle. So that means if I use Pythagorean theorem, remember how it's a squared plus b squared equals c squared, or c squared equals a squared plus b squared, I could substitute this stuff in and go, well, that means sine squared, sine of the angle squared, plus cos of the angle squared. Oops, I'm falling for my own thing I've warned you guys about. I'm putting the square in the wrong place. The square should actually be on the function name, right? Not on the angle, is equal to 1 squared. 1 squared is 1. So that gives us a really important definition. So when we get into doing these, I'll show you where it pops up. But long story short, anytime I see a 1, I can replace it with sine squared plus cos squared. Or, more importantly, anytime I end up with sine squared plus cos squared, I can just eliminate all that and replace it with 1, because sine squared plus cos squared is 1. So keep this one in mind. This one is the big one. Everything else we should know so far. We know all of this. We know all this. We've talked about them. This guy's new. Now, for those of you who are really savvy, if you rearrange this, and I'm not going to bore you guys to death rearranging these right now. We would do that in class normally, but I'm going to cut that out right now. You can take this and mess around with it using these guys over here, okay, and these guys. And you can actually come up with some different ones. Let's say secant squared, you can rewrite as 1 plus tan squared, or vice versa. And cosecant squared, you could rewrite as 1 plus cotangent squared. The good news is, for anything I'm giving you today, you can survive without those ones. So all you really need are all of these guys, which we should know, these two, and this guy is the big one to keep in mind. He's the new guy, not totally new, but the one we really want to keep in mind. Okay, so let's talk about what we're going to do, and then I'm going to do some of these. Okay, So this will be on your handout, so I'll just skim through this and you can read it yourself. But these are some of the big tips you might want to use when proving identities. Now, when you prove it, again, with the homework with this, it's very important you do a neat job and you follow the format. If you take a lazy route and you hardly show any steps and you don't break this into two halves and whatnot, you're not going to get the credit that you might think you deserve. So it's not always obvious that both sides of a trigonometric expression are equal. To do that, we want to prove it, okay, by showing that both sides are equal. All right, well, how are we going to do that? We're going to separate the equation, or the equation identity, into two separate expressions. So we do not want an equal sign between them anymore. It's no longer an equation. You're going to break it up, okay? You have to do that if you want your work to be given credit. The general tip is try to simplify the most complicated side first until it looks like the other side. Right? Like, so for example, let's think of something like from grade 9. Like if I had 5x, plus 1, plus 7 minus whatever, and on the other side I have just like a single number, this would be the side I'd probably want to attack, right? If I can simplify it and make it look like that other side. Again, I'm just kind of writing out some random stuff that might not make perfect sense in context. The idea is attack the more difficult side first. Or you can also work on both sides of the expression at the same time until they both look the same. So at some point, we want to show that these two are equal, whether we change just one side or we change both sides, okay? All right, so how are we going to do that? Well, here's the tips. Okay, anytime you run into tan, this is my first tip. I'm just giving you the tips that helped me out when I was your age to solve these things, okay? So anytime I see tan, right, I'm going to rewrite it as sine over cos. And same thing, as soon as I see cotangent, I'm going to write it as cos over sine. So that. Rate all the reciprocal functions, cosecant, secant, cotangent in terms of sine, cos, and tan, right? So go back and look at that table we just talked about. Look for parts of the expression you can replace with a Pythagorean identity. We just talked about that above, right? If you have fractions, we want to get common denominators, right? That comes in a lot. And look for places where we can factor, okay? So common factoring, trinomial difference of squares. So I'm going to walk you through a bunch of these that show that kind of stuff, okay? Here we go. Okay, in example 1, we want to prove that secant theta equals tan theta times cosecant theta. Now, you're not going to maybe like this, and a lot of math teachers would definitely not like it, but anytime I write these, I'm going to ditch the theta because it doesn't matter in this case. We're not actually solving for theta. We're not actually, finding the angle. We're just proving these two signs equal. So the true, if you're presenting this in a university solution or something like that, yeah, you want to include it. But just because I got to write a million of these just to save time without writing a million thetas, I'm going to leave the thetas out. So if you're like, wait, where did they go? This is me being a little bit lazy, but it's because I got to record so many of these videos every single day, and we're just going to try to keep it moving along. Okay, so now the main thing, though, if you want your work to be accepted, okay, is you need to break this thing down to the left side and the right side. There should be no equal sign between them. And some of you, we've been yelling at you about this since grade 9. You got to do this. Left side, right side, or you're not going to get credit. I'm not even going to look at it. Okay, so the left side is secant. I'm going to ditch the theta. The right side is tan cosecant. And again, tan, secant, cosecant are all supposed to be written in lowercase, but I write everything in uppercase. So this is another one where I'm going to get yelled at by the math gurus of the world, and for the record, they're right, I'm wrong. Okay, but the proving it part we can all agree on. Okay, so first of all, let's see. Well, what is secant? Let's rewrite that as its reciprocal. Secant is 1 over cos. Now, any of these, just go back to that table that we started with. You can find all those things right there. Okay, 1 over cos. Not much else we can do with that, can we? What about tan? What can tan be written as? Well, tan is sine over cos, and cosecant is 1 over sine, right? Well, we can reduce here, right? Sine divided by sine, it's the same thing. We can cancel, right? We just have 1 and 1. What's left on top? 1 times 1 on top is 1. Cos times 1 on the bottom is cos. There you go. We just proved the two are the same, right? See how over here and over there we have the same thing. All right, so there's the first one. Hopefully it gives you kind of the gist of what we're going for here, right? We want to rewrite these and see if we can make the two sides look the same. Now again, a lot of this is about the format. How do you present your solution, right? This is what we're looking for. Something that actually, right, breaks it into two sides, not just a sloppy, mess where you keep the equal sign in the middle, okay, if you want to get marks. All right, let's keep rolling. Okay, here we go again. I'm going to break into the left side, which is secant. And again, I'm going to ditch the thetas and just write a secant times 1 plus cos. And again, these are supposed to, the proper form, again, proper, right? If you want to do proper form, we're supposed to include the thetas. We're supposed to write in lowercase for trig function names. And again, it's almost a heresy in some math teachers' eyes, but we're just going to keep this rolling. I've always written in block letters, which is generally all capitals. So, all right, so here we go. Now, what can we do over here? Well, let's focus on the left side first. I can distribute this, right? Why don't we distribute and see what we can do here? All right, so secant times 1 is secant, and secant times cos is secant times cos. So I'm just going to write secant cos here. Right now, again, it would make more sense if I had my thetas in there. We're just going to leave them out. Secant times cos. I'll even put a little dot there. Okay. Now, what is secant? Secant is 1 over cos. And what's secant over here? Also 1 over cos. So we got 1 over cos times cos. Well, cos divided by cos is 1, right? So they cancel out. All right. So what do we got over here? We've got 1 over cos, right, plus 1. Now, I could leave it like that, or I could go even work on the other side and go, well, wait a minute. Like I could rewrite this as secant if I want, right? I could do it like this and go, wait, that's secant plus 1, because 1 over cos is not secant again. So you might be like, well, why did you make it into that? Again, a lot of this is trial and error. So I'm realizing, wait a minute, look on this side. I got 1 plus secant, right? Well, 1 over cos, I'm just going to put that back into secant here, right? Oops, there we go. So that's back to secant plus 1, right? And I can flip around and go, look, it's 1 plus secant. Cool, they're the same. Or maybe some of you stopped here. So here's the thing. This is maybe when you're starting out. A lot of people think, oh, there's only one path to get there. That's not the case. I did prove it. Look, right? These are the same. Didn't I just prove they're the same? There they are. So there's one way of doing it. As long as we can get them to be the same, it doesn't complete. I mean, we want to do it mathematically. We want to be correct. But there's multiple paths. So what if I just stopped here on this side and said I give up? I could go over here and go, wait a minute. Okay, so what's secant here? Well, secant is 1 over cos. Yeah, I can flip that around and make it 1 over cos plus 1. Aren't they the same? So the important thing is proving that they're the same. It doesn't necessarily matter what we get at the end, as long as we can prove that the two sides are the same. So there's two different, conclusions I came to, or two different expressions I came up with more appropriately. But the conclusion is that they're both the same. All right, so let's check out another one. Okay, here we go with number 3. Let's first start, again, like every time, breaking into the left side and the right side. Now, in this case, there's really very little to do on the right side, right? It's just tan. So right off the bat, you know what I'm going to do? I know tan is sine over cos. I'm going to do that and just stop there for now, okay? Tan is sine over cos. Now, maybe I can go further, maybe not, but I'm just going to leave it like that. On this side, we got secant squared times cos theta divided by cosecant theta. Okay. Now, what I like to do is, when I have a fraction and I'm proving identities, I prefer, and I think a lot of you would prefer, write it in what we call inline. Make it an inline statement, which means instead of writing as a fraction, this fraction bar here, instead of writing that, that's called an obelisk? No, a solidus. We're going to write it with an obelisk, which is this guy, right? This symbol here. I'm getting my symbols mixed up. So I'm going to write it like that instead. Now it's all in one line. Maybe it makes a little more sense. All right, so let's see if we can make some sense of this. Well, secant is 1 over cos. So that means secant squared is 1 over cos squared times cos. Now, what's cosecant? Cosecant is 1 over sine, right? So here we go, 1 over sine. Now, some of you might see some stuff that can be reduced already. I'll do that in the next step. Now, cos squared, you don't have to write it out twice, but I'm going to write it out twice to be clear because people always cancel out too many of the coses. So cos squared, we have 2 of them, 1 over cos times cos. Divided, let's change that to times. And we're going to, when we're multiplying, right? When we're dividing by a fraction, we're going to multiply by the reciprocal times sine. All right, well, what can we do here? Cos and one of these coses can cancel out. And let's look at what's left. What's left on our numerator? 1 times sine. That's all that's remaining up there. So we have sine on top. And on the bottom, all that's left is a single cos. So it's cos. Look at our two sides match up. Now again, if I didn't do anything on this side, what if I had just left it as tan, right? I could have taken this a step further and said, well, sine over cos is tan. And I could have just stopped there and said, look, this is tan and this is tan. I could have just proven it that way. So again, you can prove it more than one way. You can work on only one side or the other side. So again, if I don't want to write that, if I want to just go one more step further on this side and say, hey, that's tan. There you go. Okay. All right, let's try some more. So again, this takes some playing around. This is where people get really frustrated on these when they start because they basically, everyone's, wants just tell me what to do. Tell me step 1, tell me step 2, tell me step 3. Well, these you have to play around a little more. They're like a puzzle. Okay, and to solve the puzzle, you have to follow those first steps I talked about, right? You have to go back, read them through. What are we going to do? Rewrite the reciprocals, rewrite tan, rewrite cotangent, right? And then we're going to do some reducing and things like that. All right, here we go. Oops, with example 4. All right, I don't know where the 4 went, but this is example number 4. All right, let's break it down again. Left side, right side. Now, the right side of this one, not a lot going on. The left side of this one, a whole lot more going on. Sine times secant divided by tan. All right, so start by writing it out, okay? Set that format up. Show me that you know that. All right, now, I'm just going to leave the right side alone, see what we can do on the left side right now. So again, I'm going to write this as an inline statement, which means it's in one line, okay, instead of the fraction. So I'm going to write divided by tan here, okay, using the obelisk symbol, okay? All right, so now we have sine times secant. Well, what's secant? Secant is 1 over cos. Divided by tan. Well, what's tan? Tan is sine over cos. So we're dividing. So we're going to change that to multiplication. Multiply by the reciprocal. 1 over cos times cos over sine. And this one, this is just another one like question 1, 2, and 3. Question 1, 2, and 3 are all about just rewriting and reducing. Look at cos divided by cos is 1. Sine divided by sine is 1. What's left? 1. That's all you have left over because this is 1, 1, 1, 1. So 1 times 1 times 1 divided by 1 times 1. It's just 1. Done. There you go. I proved the two are the same. Didn't have to get too carried away there. Pretty easy. Let's move on to number 5. Okay, here we go with number 5. Not going to worry too much until I get everything set up. So we have cotangent squared, and on the right side, we have cosecant squared. And again, purely out of laziness, I'm not writing the thetas every time, but if I were handing this in to my professor, I'd be a little neater on this. Okay, now let's start on the easy side here. Cosecant squared. Well, cosecant is 1 over sine, so cosecant squared is 1 over sine squared. That's about all I can do so far. I mean, you could go crazy and write this as 1 over sine times sine, but I don't think we need to get that carried away yet. Okay, so let's just leave it like that. Now, what's cotangent? Cotangent is the reciprocal of tan. Tan is sine over cos, so this is cos over sine, right? Or cos squared over sine squared. Now you could write like that, or we could make the entire fraction squared. I'm just going to write them each individually as being squared. All right, now, this is the first one where we have a little bit more of a challenge. Right? What are we going to do? People, I see this one all the time when they do this, and it's the first one where people really get stuck. They get there and they go, okay, I wrote the reciprocals. I have no idea what to do now, right? Well, let's compare. What do you have over here? One fraction, right? What do you have over here? A fraction plus another number. We're going to have to add these together at some point. What do we need when we're adding fractions? Common denominators. So this one here is over 1, isn't it? So we need a common denominator. Well, what's the common denominator for 1? And sine squared. It's going to be sine squared. So what am I going to do? I'm going to multiply this by sine squared. I'm going to multiply the numerator by sine squared. All right, so what do we end up having here? Sine squared plus cos squared over the common denominator of sine squared. All right, now this is where the newer, we've talked about before, but the newer rule comes into play. Remember the Pythagorean identity. That's this guy right here. So if you look back at that table or you look at your note if you printed it out, what's the Pythagorean identity? It's this guy. Sine squared plus cos squared equals 1. So that means I do have sine squared plus cos squared right here, right? And that means I can replace that with 1 because they're equal to each other. It's an identity that's already proven. So here we go. I can just rewrite this as 1 over sine squared. And look at, ta-da, they're the same. So this one wasn't a lot, but this is the first thing you want to be aware of. And like they say, where there's a will, there's a way. If you are willing to go back and look at the examples, watch the videos, and keep reminding yourself, this is where some of you are you're gonna be stuck. You're never gonna move forward, and this is where some of you are gonna get over the first hurdle. The first hurdle is getting common denominators, right here, and looking for opportunities to find common denominators. Okay, so you get stuck. Look at the two sides. One has 2 fractions, the other one has 1 fraction. So we're going to have to combine these, which means a common denominator, right? And then we use the Pythagorean identity, right? So again, the first time you do one of these, yeah, it can be very frustrating, right? The more you do it, you start looking for these scenarios, okay? So this is a really important one because it's going to pop up a lot where you can get a common denominator. All right, let's check out another one here. Okay, here we go with example 6. Again, left side is just tan theta. So not much to do over there. The right side is sine plus sine squared theta, okay, divided by cos theta plus sine theta times cos. All right, I'm just put a little dot there to indicate they're multiplying. Okay, so not much we can do on the left side, right? All you can do is rewrite that as sine over cos right now. I shouldn't say all, but pretty much where we're going to get stuck at right now. Now, the secret to this one is common factoring. Look at the numerator. Sine plus sine squared. What if instead I wrote y plus y squared? And I said common factor that. You know quickly to go, oh, I can make that into 1 plus y. Common factor out of y. Same with the bottom. What if I took the bottom here and I wrote that instead of cos plus sine cos? What if I went it was x plus yx? Right? Say, oh, that both of those terms have an x in them. So we can common factor out an x, and we're left with 1 plus y. Notice how we're left with the same thing there in the bracket? So I'm going to do exactly that, but instead of, right, and why am I using y's and x's if you're wondering? I'm just trying to put in more simple terms. That's something we're more comfortable with. It's the same premise though, right? We can common factor out the function sine, and we're left with 1 plus sine. We can common factor out a cos on the bottom, and we're left with 1 plus sine on the bottom also. And that's really all there is to this one, because 1 plus sine divided by 1 plus sine, we can divide the entire factor by the entire factor, and they cancel out, and we're left with sine divided by cos. There you go. The two sides are the same. We've proven the identity is true. And what do we mean again by proving identity? We've proven that tan theta is this whole mess, right? That those are equal. It's true. All right, let's just do a couple more, and then that'll be it. Okay, here we go with number 7. Let's start by writing out our two sides. Okay, 1 minus cos squared theta, and the right side is going to be cos squared theta times tan squared. All right, now this one is going to include the Pythagorean identity a little more, and you can kind of work on either side you want. Some of you might look at this side right away and be stuck and be like, well, I don't know what to do. I'm going to show you a trick that you can do with this at the end, okay? Let's start on the side that looks a little more familiar, right? Cos, okay, this side's cos squared, no biggie, and times tan. Well, tan can be written as sine squared over cos squared, right? Because tan is sine over cos, tan squared, sine squared over cos squared. And right off the bat, all right, these two cancel out, and then we're left with sine squared. And then you hit a bump right here. All right, so when you hit these bumps, and you're kind of like, well, what do we do now? There's nothing we can do. Look back at your formulas, and this is where that Pythagorean formula is going to come in huge again. So let me write it down. And we can approach this a couple of different ways. Pythagorean identity, right? What does that say? It says sine squared plus cos squared equals 1. Well, you can fiddle around and use this a lot more than you might realize. So when you get stuck, start by writing this down and say, okay, well, let's focus on the sine squared for a second. What would happen in this if I isolated the sine squared? So what if we subtract a cos squared, which effectively moves it to the other side, right? We're going to subtract cos squared from both sides. And what we end up is 1 minus cos squared theta. That's this right here. So the whole point of this question is really so we can teach you how to use the Pythagorean identity a little more. Now, again, when you're doing your homework, I totally get how these things are frustrating. I have a vague memory of sitting in like my bedroom at my desk trying to do some of these and just like pulling my hair out, not knowing what to do. It is a struggle. Try your best. But this is another huge tip, okay? Pythagorean identity, being able to rearrange it. So that means sine squared equals 1 minus cos squared. I could also rearrange cos to isolate cos, right? And couldn't I make that 1 minus sine squared? So there's two different ways. So anytime we're stuck and we kind of hit a space, we can rewrite sine or cos as one or the other. So if I want, it doesn't really matter here. I could rewrite this side as 1 minus cos squared, right? And say that they're the same. Or I could just rewrite this guy as sine squared and say they're the same. So there you go. We've proven that these two are the same. So it didn't take a lot of work. It just takes this knowledge of knowing your Pythagorean identity really well. So the Pythagorean identity kind of has three big uses. The first use is anytime you have sine squared plus cos squared, you can replace them with 1. Or if you want to isolate the sine or isolate the cos, right, you can replace them with 1 minus cos squared and 1 minus sine or vice versa. So like here, I replaced 1 minus cos squared with sine squared. Or I could have come over here and wrote it down there like I did earlier. All right, I think we're just going to look at one more here. I'm going to do two more, but the next one, I'm not really going to give any questions on, but it's a really good one. So I'm going to show you one here, And then I'm going to do the last one, which is really important. Okay, so like I was saying, I like this one, but there are many, many more I'd normally do. We do a couple days this. I'm just going to kind of keep it to the day one important ones to really get you going. All right, so the left side is 1 plus cos squared. Okay, sine over 1 plus cos squared, sorry. And the right side is 1 minus cos theta over sine. Okay, all right, so we got our two sides. Now this one is one of the more tricky ones. I want to show you for those of you who want to see how it's done, but I don't think I'm going to assign you many of these. If I do, I'll even point out that to follow exactly example 8. All right, so the trick to this is there isn't really a whole lot we can do. Now, some of you might be like, oh wait, 1 minus cos, can't we replace that with sine squared? No, that only works if this was 1 minus cos squared. Okay, so remember our Pythagorean identity says sine squared plus cos squared equals 1. So that's not going to work here. I don't see any squares. So this one, what we're going to do is we're going to pull a trick that we learned a while back. We're going to multiply. It doesn't really matter which side we start with, but I'm going to start with the left side. I'm going to multiply it by what's called the conjugate. Now, if you remember what the conjugate is, it basically creates a difference of squares. So I have 1 plus cos. I'm going to multiply it by 1 minus cos. Okay, and I'm going to multiply the top here also by 1 minus cos. So what I'm really doing here is I'm actually multiplying by 1, right? So I'm not changing the value of this expression at all. I'm just changing what it looks like. So we're actually multiplying by 1. Now, what that does is it creates, it's called the conjugate, right? That's what we're actually multiplying. And it creates a difference of squares. Okay, so it's called a conjugate. It's going to create a difference of squares. Okay, now what's the difference of squares? Remember when we're multiplying, I'm just going to use triangle and square here. Triangle plus square times triangle minus square equals the two sides, two terms squared minusing each other. That's a difference of squares. So over here, what I can do is I can rewrite my denominator now, because 1 times 1 is going to be 1, 1 times negative cos, 1 times positive cos, they're going to cancel out, and cos times cos can be cos squared. So I'm going to have for my denominator is 1 squared, which is 1, minus cos squared. Right? That's using the shortcut for difference of squares. Now the top, we're going to actually have to do some multiplying, right? So we're going to go sine times 1 and sine times cos. We're going to distribute. All right, so I have sine, which is sine times 1, minus sine times cos. All right. So again, this one's a little tricky. This one, like, I would not expect a lot of you to get this one off right off the bat. This one takes a little more manipulating. And some of these you can get really complex and wild. So this one's just, it's getting out of the easy, beginner territory. Now we're getting into some more complex techniques. All right, so now we did that. Now on the bottom, remember our Pythagorean identity we just talked about? We're going to use that same thing we just did in the last lesson. Now we have some squares. Notice how we have 1 minus cos squared? Well, isn't that the same thing? I'm just going to go up here and remind you of the Pythagorean identity, 1 minus cos squared, right? Pythagorean identity says, hey, I can rewrite this bottom as sine squared, right? Now, to be honest, I'm not sure why I multiply these up top. I'm actually going to common factor the sine out of there so it actually looks like this. So I'm just going to common factor the sine out of both of these now that I'm thinking. I'm kind of just thinking my way through these as I do them with you, right? So it's going to be back to 1 minus cos here, right? Now, why the heck did I do that? So that I can cancel one of the signs with one of the signs here, because we have sine squared on the bottom, so there'll be one sign left. So all that's left is 1 minus cos over, there's still one sign left. There you go. The two sides are the same. It worked out. Like I said, not a lot of work, but really knowing your math helps a lot out here, right? All right, so we use the Pythagorean identity, and we multiplied by the conjugate. That one getting a little wacky, a little wild. Let's do one more, one of our favorites. This is a big favorite in grade 11, final one for today. All right, here we go with number 9, a grade 11 favorite. This one's going to involve getting common denominators. Now, how do I know that? Look at, we got two fractions up there at the start, right? So we got 1 over 1 minus sign minus 1 over 1 plus sign. All right, so we're going to need to get common denominators here. So you can do it a lot faster than I am, but I'm going to break it down a little bit more slowly here. I'm just going to work on the left side. You could definitely skip a couple steps here if you really know what you're doing. All right, so the common denominator is going to be, let's multiply these two denominators together, right? You know what? In fact, let's not. Let's learn how to shortcut this a little bit so we're not always dragging our feet. You guys are ready, and you should know this anyways. Like, let's say you have A over B plus C over D, right? Well, what do you end up doing? You end up multiplying the two denominators together, right? B times D. And you end up multiplying this numerator by B, or D, and this numerator by D. You end up going A times D plus B times C, right? So for example, if I have 2 over 3 plus 4 over 5, the common denominator is 3 times 5, right? Which is 15. And then what do I have to multiply the numerators by? You have to multiply 2 by 5 and 3 by 4, and you end up multiplying them, right? 2 times 5 is 10, 3 times 4 is 12, and then you simplify your numerator, right? And then you can obviously reduce this and all that. All right. Oops, 12, 22. Adding's hard. All right, so it's the same thing here. What are we going to do? We're just going to multiply these two denominators together, right? And we're just going to multiply the numerator by the opposite one's denominator. So instead of dragging this into 4 or 5 steps, if we've made it this far, we should be able to multiply or add and subtract fractions, right? So I'm multiplying the denominators together, right? 1 minus sign, 1 plus sign. All right, and I'm going to multiply him by his numerator and him by his numerator, right? So I end up having, let's be careful, I'm going to keep them in brackets for now. 1 plus sign minus 1 minus sign. Now we have to be careful. You have to have brackets because you're going to have to distribute that negative, right? All right, so let's do that. Let's start cleaning things up. So on the top, we have 1 plus sign minus 1 minus negative sign plus sign, right? Now, let me clear this away. What do we have on the bottom? At this point, you've done it in grade 10, you've done it a lot in grade 11. The bottom should look very familiar to you. It's the same thing we just encountered in the last question. This is a difference of squares. So you can multiply it the long way, but what's the shortcut? The shortcut says if you are multiplying two terms by the exact same two terms, except the difference is one's plus and one's minus for the second term, the shortcut is square the first term minus the square of the second term. It's a difference. That's what the minus is. That's the difference part of squares. These are both squared, right? So to get my denominator here, instead of multiplying it in 2 or 3 steps, all I'm going to do is square the first term. 1 squared is 1. Square the sine. Sine squared is sine squared, and subtract them. So that's just our shortcut for calculating that, right? So we got a difference of squares there. Cool. So that popped up again. All right, now, if you didn't remember your difference of squares, you still should be able to get it. Why? Let's just go over here and remind you, right? Let's say you forget the shortcut. All right, fine. You go 1 times 1 is 1 squared. 1 times sine, right? Plus sine. Negative sine times sine, minus sine. Negative sine times sine, negative sine squared, right? And then what do you end up having? 1 times 1 is 1. Plus sign, minus sign cancel out. You end up with the same thing, right? It's just knowing your shortcuts really helps move things along quicker. Okay, so look at the denominator. Oh, let's clean up the numerator first over here. So we got a 1 here and a minus 1. Those are going to cancel out, so they're gone. And we have a sine plus a sine. So we have 2 sine on top. All right, well, that's making me feel good because look, notice how there's a 2 over here? Okay, I got a 2 over here. All right, so we're moving along. Things feel pretty good. Divided by 1 minus sine squared. This is where, once again, you require the Pythagorean identity. Right, so now we've seen it 3 questions in a row. So we should start getting used to looking for this. 1 minus sine squared. Remember, Pythagorean identity says sine squared plus cos squared equals 1. So if I isolate cos squared, I would get 1 minus sine squared. So that means that right there we can replace with cos squared. Because cos squared equals 1 minus sine squared. So let's just replace that whole denominator and write it as cos squared. All right, let's get rid of this stuff here. Only because I'm running out of room, I'm just going to, instead of continuing going down the page, I'm just going to bring it up here to continue my left side. All right, so let's break this down a little bit more. Let's think this through. We have a 2 times a sine, right, times 1 over cos squared, which is 2 coses, right? Isn't that what we have here, right? Well, can't we just smush one of these, right? Because this is all multiplying. So I'm going to rewrite it a little more. I'm getting a little carried away with how I'm rewriting this, but I really want people to think this through. I'm going to put one of these signs underneath, one of the coses underneath the sine. 1 times cos, right? Look at that. I'm just moving him, because it's all multiplication. It's over 1, so I'm just going to move him over there. All right, so what do we really have? 2 times, what's sine times cos? Sine divided by cos is tan, right? So 2 times tan. And what's 1 over cos? Isn't that secant? There you go. It's the same as this, right? Yeah, some of you might say, well, what if I didn't do that? All right, so I've proven they're the same. That's good enough. Let's say you didn't. Let's say you got to the other. You stopped here instead. So let's say you didn't do it that way. So I'm just showing you different ways. Let's say you got to here and you're like, I quit on this side. I'm gonna go work on the other side. Okay, no problem. So 2 times tan. What's tan? Sine over cos. Right? And what's secant? 1 over cos. So what do we have? 2 times sine times 1 is 2 sine on top. Our numerator. Cos times cos is cos squared. Great. I just proved that they're the same again. So again, it doesn't matter what we end up with as long as it's the same. As long as we've proven the two sides are the same, it doesn't really matter. You can do everything on one side, everything on the other side, or work on both like I did here. So long lesson. These are a little, can be a little tricky if you don't follow the tips and you don't maybe watch the video through a bit and think about all the different things. I know the first time I started learning these, it was a little frustrating until I really got the hang of it. Okay, so just try your best on these. Try not to freak out. If you're really stumped on some, I'll drop some solutions for you. So thanks for watching.